Okay, looks like we got some infinity stuff going on here. Hopefully you can see this screen. Okay, I'm just going to share what you should have got in your handout. This first thing that we're looking at is factor the following and solve for x. This is basically what your guys' assignment was on that was due on Wednesday. If you haven't turned in that assignment, can you please give it to the sub at the end of this lesson? Okay, so you don't have to move right now. You can give it to the sub at the end of this lesson. There is a question that I want to look at on this. And what's this first one? What should the value of x be to maximize the area shown below? Okay, so this would actually be a good question that you may see on a test. These kind of problem solving questions. So I'm just going to grab this here and look at it. And what we know about area, of course, is that it's a multiplication of the base times the height. Okay. So what we're going to do is multiply x plus 2, okay, times 20 minus 2x. Now, in there, it says solve in two ways. A table of values and by graphing. Okay, I'm going to solve it by graphing first because then my table of values can become really easy. And I'm trying to compress this because you guys had a celebration today for the Feast of St. Paul. Okay, so if we go solve by graphing, I'm going to go by Desmos. And I'm just going to open it up here. I'm going to say y is equal to x plus 2 and 20 minus 2x. I think that was what it was. Let me just check. Yeah, that was it. Okay, so when I go into Desmos, I'm going to zoom way out. Okay, I'm going to come in. And I can see that the value of x, for it to be a maximum, is 4. Okay, now what does that exactly mean? Well, that's where the table of values actually comes in handy. Okay, so if I go into my table of values, and I'm going to go back to the screen capture here. Okay. Oh, no, it's not on the screen capture. Okay, so if I just create a table of values, I'll just create one right now. And you guys already have one. But if I look at my x and my y, I want the value of x that's going to maximize this area. And we already know from the graph that it's 4. But let's just take a look at 2, 3, 4, and 5. Okay. So if I put in a value of 2, okay. So if x is equal to 2, I'll just do that right here. Okay. Then what we're going to get is 2 plus 2 times 20 minus 2 times 2. Okay. This is going to be equal to 4 times 16. And of course, 4 times 16 is 64. Okay. So that's an area of 64 square units, or units squared. Let's try x equals 3. Okay. So let's see, if our x is 3, what's our value going to be? Okay, so if my x is 3, I'm going to have 2 plus 3. Okay, and 20 minus 2 times 3. Okay, and this is going to be 5 times 20 minus 6 is 14. Okay, and I believe 5 times 14 is 70. Now let's look at 4. So you can see it's going up, right? Now let's look at x equals 4. I'm just going to create a bit of room here. How do I get rid of this stuff here? Okay, so let's look at x equals 4. Go away. Go away. Come on. There we go. Okay. So at x equals 4, we're going to get, of course, I erased the function, 4 plus 2 times 20 minus 2 times 4. Okay, so this is equal to 6 times 12, which is equal to 72. Okay, so this part here is 72. That's getting pretty big. And let's just check 5. So at 5, we're expecting it to start falling again. So let's check 5 now. Do, 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 do. Okay, x equals 5. Okay, so at 5, we're going to have 5 plus 2 times 20 minus 2 times 5. Okay, so this is 7 times 20 minus 2 times 5 is 10. So 20 minus 10 is 10. Oh, look at that. We got a 70 again. Yeah, so table of values method, you can definitely see that 4 is the top value. Okay. One other way that I want to show you guys how to do that is actually with your TI calculator. Your TI calculator can actually give you this, and it's using the table function. Okay. If you get a chance at the end of class, see if you can use the table function to figure that out. Okay. The other problem on there was a river problem. This is a fun problem. Okay, so we're going to have a new snip here. A farmer has 100 meters of fencing to enclose his cattle next to a river. How big should his sides be to get a maximum area? What should that area be? Okay, so we're definitely going to get some values here. We're going to get some real numbers out of this because we're given 100 meters of fencing. And it gives us a hint to solve by graphing. Okay, but that kind of hint is actually further on in the problem. First, we're going to have to set up our sides here on what they should be. Now, one thing that I always do is I always just label these sides, these heights, as X. Okay. Now, what do we know here? I know that I've got 100 meters of fencing to deal with. Okay. And I've got 2 X's here. Okay. So if I've got 100 meters of fencing, I've got to put that into my problem. I'm going to put it in on this side, 100. Okay. And I've also got to deal with these X's here that I have. Because I've added 2 X's on the height, I'm going to take away 2 X's on the base. Okay. Because if I look at this 3-sided rectangle, the perimeter of it is going to be X plus X plus 100 minus 2X. And what we can see algebraically is that if we cross out, I've got an X, a 2X, and then a minus 2X. These things actually just cancel out, and I'm left back with my original 100 meters. Okay, so this will actually work for our algebraic component of this problem. What I'm going to do is I'm going to now find the area by multiplying base times height. So I'm going to say X times 100 minus 2x. Okay, now this is actually technically enough to put in GeoGebra. You may want to distribute the x though. So in this case, we would have 100x minus 2x squared. And I know this is a quadratic. I know that this is a quadratic because why? Right, because of this little 2. Okay, so let's put that into Desmos. Desmos the man. Okay, 100x minus 2x. Deedly-dee, okay, 100 minus 2x squared. Let's see where the max is. We're going up, we're going up. Boom. The max is at 25 and 1250. Okay, so let's go back to our problem there and figure out what that means. So first of all, my x is equal to 25. Okay, and my y was equal to 1250. So let's take a look here. If my x was equal to 25, that means these up and down sides would be 25 meters. Okay, and that means that this bottom side here would be 100 minus 2 times 25. And 100 minus 2, and of course 2 times 25 is 50. So 100 minus 50 is 50. So if you guys look, 25 and 50, and this other side of 25, that would give us 100 meters of fencing. And you'll notice that 50 times 25 is equal to, guess what? This 1,250 meters. So it's kind of an interesting little problem that you should definitely take a look at in the future. Okay. Biggest part of it, though, is setting up this piece right here. Okay. And you can do it with anything. You could do it with a square. Here's a problem that you might want to try. If I could find the painter. There it is. Okay. So say if a farmer had 300 meters of fencing. Okay. And he wants to know how big of a rectangle he could have to have the maximum area. How would you set it up? Okay. So in this case, we have 4 to set up. I'm going to start it the same way. Oops. I don't know what I'm doing here. Okay. So I always call these X. And somehow I've moved into spray can. Okay. Now, this side and this side have to add up to just 300. Okay. So I can't just say 300 minus 2x on the bottom. I'm going to say half of this distance minus an x here. And then for the top, I'm going to say half of this distance and minus an x here. Okay. So I'm going to say 150 minus x on the bottom. Okay. And 150 minus x on the top. Okay. What I want you guys to do, take this home, solve it. Okay. Tell me what you get on Monday. Okay. Tell me what you get on Monday. And that's it for this video. I'll see you on the next one where we shall complete the square.